All right, we need to spend a little bit of time with the rules in this game. First of all, we're being asked to put things into groups. So I've got groups, people in area 1, area 2, area 3. And then the first several rules are pretty straightforward. M is in area 3, so there she goes. And oh yeah, from that setup information, 1 in every area, but no more than 3. And I'm just holding on to that in my head. If you feel like you need to, you might do something like this to remind yourself that you get up to 3. Then O and P are not in group 1. Third rule, L is with K or M, but she ain't with both of them. So I've split that up so I can see it very clearly. Now it's the final rule that I wanted to spend some time with. From rule 2, O is not in area 1. So O is in area 2 or else area 3. There's only 2 possibilities for O, 2 or 3. And the rule 4 says if O is in area 2, then something happens. Otherwise, something else happens. So I'm splitting it into 2 distinct rules because that's what it is. If O is in area 2, something happens. Otherwise, and that otherwise is the only other place O can go. O is in 2 or 3. So if O is 2, something happens. If O is not 2, that means she's in 3, and then something else happens. So you split them into 2 and deal with them individually, and you have no problem with it because you know how to do conditional statements. And if you don't know how to do conditional statements, check out some of our lessons on them. It behooves you to get good at them. So if O is in 2, then J and K are together. So if they're split up by contrapositive, O is not in 2, she's in 3. Otherwise, if she's not in 2, they're not together. So if they are together by contrapositive, then she must be in 2. All right, let's answer questions. Question 6 gives us a global account of all of our rangers and their park areas. Answer choice A breaks that third rule. You can't have L and K. You must have L with K or M. Answer choice B breaks the 4th rule. If you've got O in area 2, J and K have to be together. If J and K are split up, O wouldn't be in 2. Answer choice C, rule 2 is broken. You can't have O or P in area 1. And answer choice D breaks our first rule. M has to be in area 3. And that leaves us with only answer choice E, and that's why that's the right answer. Moving on, question 7. If Olsen is the sole ranger, the lone ranger, if you will. Fair enough. In area 2, and notice what I'm going to do, visually box it, and that just says to me Olsen is alone, so I don't try to stuff somebody else in there and then ruin the question. Who could be in area 3? All right, well, let's talk about what this means. Always M here. And Olsen is in area 2, which means that J and K are together. And you can't put J and K and M together because where will L go? So K and M can't ever be together, right? And maybe we're noticing this now. And if we're not noticing it now, that's fine. We'll do it every single time we apply the rules. That's the whole point. When you apply the rules, you get to anything you need to discover. All right, so J and K can't be here. They'll have to be over here. L has to be with one of them. P can't be here. P must be here from rule 2. And then L either place, over here or here. That's question 7. What were we asked? Who could be in area 3? Well, M and P, or M and P and also L. And we got only answer choice C. All right, question 8. One ranger in area 1. What has to be true? Well, let's think this through. That one ranger can't be O or P. They're never in area 1. Can't be M. She's never in area 1. Can't be L because L can't be alone. So that just leaves J or K. So that single ranger is either J, else K. All right. Either way, we have split up J and K. So rule 4 takes effect. When we split them up, O has to be in 3. And now in this first line, if J is here, K can't be with M because that leaves no place for L. So K will be here. And then L can go either place and P can go either place. I don't know about them. All right. Second line, if K is here, L has to be with M. And we have to have somebody here. And it's going to have to be, since we filled up space 3, it's going to have to be both J and P. What must be true? Olson is in area 3. Yes, that must be true. All right, question 9, a ranger that cannot be assigned to area 3. Notice one thing you can do is just look back and see that we've already had L, O, M, and P in area 3. All of them can be. ABC gone. Who can't be, J or K? Oh, we've been through this. How are you going to put K in area 3? Put K in area 3, then L has no place to go. K and M and L cannot all be together. All right, so D is correct. Question 10. If K is in area 2, what could be true? Well, it doesn't say that she's all alone. Just says she's in area 2. We know M is here. And now we've got to have somebody in area 1. And this is that same count we did earlier. You can't have O or P or M. And now we can't have K. So we have only J and L left, right? And L is not in area 1. She's with one of these guys. So it's J. And see, the ability to count to 6 is a highly useful skill in the LSAT. L is in one of these places. O, from rule 4, because these guys are split up, has to be here. And then P, either one of those places. Nothing else about P. What were we asked? What could be true? Pruitt could be in area 3. Like we said, we don't know about P. Just not in area 1. All right, question 11. L and O are in the same area. Well, if L and O are in the same area, that is in area 2, else 3, right? Right. All right, if they're in area 3, then we've got a rule about it. J and K have to be split up, so one of them will be here, and the other one will be here, and then P can't go in area 1, so P would be there. If L and O are in area 2, we have a rule about O. If O is in 2, then J and K are together. Well, L has to be with M or K, she'll have to be with K, and also J, and now we have overloaded that second area, so we can't actually do that one at all. So if they're in the same area, then they have to be in area 3 together, and what could be true? K is in area 2? Yeah, that could be true. That leaves with just question 12. If J is in area 2, what has to be true? What do we say? J is in area 2? And we've got M. And again, we can start by thinking about area 1 and counting to 6 again. It's not M, it's not O, it's not P, now it's not J. So we've got only K and L left, right? So either K is there or else L is there. And if K is there, then we've got K and J split up. So O has to be in 3. And L is either with them or with K. And P may be here or may be here. If, however, we've got L here, then we've got to have K, right? L has to have K or M by her side. And in that case, K and J are split up, so O is here, and P will be either here or here. And we don't care about any of that because we were asked what must be true. And what must be true in both instances is only that K has to be in 1 or O has to be in 3. And we got a K is in 1. And that finishes off this second game.